Core OpenGL concepts, coordinate systems, vertices, shaders. In OpenGL, the coordinate system is a 3D Cartesian coordinate system, which means it uses three axes to represent positions in space. These axes are typically labeled as X and Y and Z. So, ganito yung itsura ng Cartesian plane sa OpenGL. Ito yung y-axis. Ito naman yung x-axis. Ito naman yung z-axis. Ganyan siya. Tapos dito naman sa x-axis, ito yung horizontal position with positive value to the right and negative value to the left. Ibig sabihin, kapag ganito yung direction niya, positive, pag pa left naman is negative. Tas dito sa y naman, sa y, okay, yan, sa y, it represent vertical ito, patayo siya, with positive value upwards and negative downwards. Positive siya pag pataas, pag pababa siya is negative. And then dito naman sa z-axis, it represent depth or distance from the viewer. Tas pag positive naman siya, ganito siya, coming out of the screen, papunta siya dito, positive. Ayan, papunta sa'yo. Tas punta naman doon, yan naman yung negative. Ang tawag sa coordinate system na to is right-handed coordinate system. Next is vertex. Vertex is a point in 3D space that is used to define the shape of an object. A vertex is defined by its position in space and other attributes such as color, normal vector, texture, etc. Itong vertex, ito yung bumubuo sa shape na gagawin. Ito din yung magbibigay ng mga definition sa mga shapes. Vertex represent points in the space and are defined by their coordinate in Cartesian coordinate system x, y, z. Vertices are typically grouped together to form primitives such as points, lines, and triangles, which are then used to construct more complex shapes. For example, to create a triangle, you would define three vertices with their respective coordinates. These vertices are then assembled into a triangle primitive which rendered on the screen based on the coordinates of its vertices. Tulad niyan, nasa picture yung triangle sa left side. At yung nasa right side naman, yun yung mesh. A mesh is a collection of vertices along with additional information such as texture coordinates. Meshes are composed of individual primitives such as triangles, quads, or polygons, which are formed by connecting vertices in a specific order. Dito sa mesh, ito yung madaming vertices na ito yung paggawa ng mga complex object. Once na natapos na yun, it can be rendered on the screen using OpenGL's rendering pipeline. Tapos, pag nagawa na yung object, dyan napapasok yung shading effects, mga pag-apply ng lighting sa object para mas maging 3D talaga siya, maging realistic sa paningin ng tao. Shaders in OpenGL are small programs that run on the GPU or graphic processing unit and are responsible for various stages of the rendering pipeline. There are two major types of shaders in OpenGL. First is vertex shader. Vertex shader are responsible for processing individual vertices of a mesh. They perform operations such as transforming vertex position from other object space to clip space, applying lighting calculation, and passing data to the next stage of the pipeline. Itong vertex shaders, ito yung responsible sa position ng ating object sa space. Next is fragment shader or pixel shader. Fragment shaders operate on individual fragments generated by rasterizing primitives. They determine the final color of each pixel based on factors such as lighting, texture, and surface properties. Itong shader, ito yung magbibigay ng mga effects, ito yung magbibigay ng color. Sa madaling salita, ito yung magbibigay ng ng buhay sa object na ginawa natin. Ito din yung magbibigay sa atin para maging 3D yung object.